Okay, this is the extra practice converting rectangular equations to polar equations. So there are 4 additional problems here for you to work through. I would encourage you, because this should be done after watching the notes video, I would encourage you with each of these to pause the video, try it on your own, restart the video either when you are stuck and need a little bit of help or have an answer and you're ready to check. You should be treating this kind of like whiteboards in class, right? You shouldn't just be waiting for the answer. You should be practicing it on your own, and then the answer would be given once people are kind of getting close to the end, right? So pause the video, try it on your own, okay? Okay, so first up, we have x squared plus y squared minus 16 equals 0. We're trying to get this rectangular equation into a polar form. We have 3 steps that were given in our notes just now. First step, substitute. So we're looking to substitute our cosine theta in for x, our sine theta in for y. And so we have an x here that we can substitute in for. So let's go ahead and rewrite this as our cosine theta, which is what x is, squared. And my y is our sine theta. And then minus 16. Okay, and then step 2, we are going to rewrite, which means simplify, factor, Pythagorean identity, something along those lines. And so in this particular case, that could mean I could square these. So r squared cosine squared theta, r squared sine squared theta. And I could also add the 16 over to the other side. And lo and behold, once I do that, I do notice that the 2 terms that are still on the left have a common factor. I can go ahead and pull that r squared out, leaving me with cosine squared theta plus sine squared theta. And cosine squared plus sine squared is 1. Okay? Which brings us to our last step, which is we're going to solve for r squared, r, or theta, whichever one is applicable. Again, that will be r squared or r unless there is no r, and then we solve for theta. Okay, in this case it means solving for r squared, which is a fairly quick step. R squared times 1 is r squared. Okay? Okay, second extra practice problem. Pause the video, give this one a shot, restart it when you're ready. Okay? Okay, step 1, substituting. We've got a y and an x in this case. Y is r sine theta. X is r cosine theta. And then I can add this 8 over to the other side, which gives me 9. Okay, we then are going to rewrite, simplify, factor, Pythagorean identities. In this particular case, there is something we can factor. They have an r in common, so pulling that r out, we're left with 2 sine theta in my first term and 7 cosine theta in my second term. Okay. Which brings me to my last step, solve for r squared, or theta. In this case, we're going to be solving for r by dividing this entire thing under the 9. Okay. Okay. 2 more here with turning from rectangular to polar. Go ahead and pause the video, give x equals -8 a shot. Okay, step 1, substituting. X, we only have an x in this case, no y, so we're substituting r cosine theta in for x. Step 2, we are rewriting, so simplifying Pythagorean identities, factoring. We don't even have multiple terms in this particular case, so we aren't going to be doing any of those. So we're brought to our last step, which is to solve for r squared, r, or theta. And again, it's tempting this one to maybe want to try to solve for theta, but one more time, we really only solve for theta when there's no r to solve for. In this case, we do have an r to solve for, so let's go ahead and solve for r. What would that mean we would do? We are dividing the cosine theta over to the other side. So we are left with r on one side and -8 over cosine theta on the other. which is the same thing as -8 secant theta. Okay. Okay, last one. Go ahead and pause the video. Give y equals √3x a shot. Restart it when you're ready. Okay, substituting, we have a y and an x. So y is r sine theta. X is r cosine theta. Rewriting, simplifying factor, Pythagorean identities, none of those are going to work. So we're going to go ahead and isolate, solve for r squared, or theta, whichever one is most appropriate. So in this case, I'm going to go ahead and divide this r cosine theta over to the other side, which is going to give me sine over cosine is tangent. And so in this case, we're going to end up solving for theta because this is an instance where we have no r or r squared to solve for. Our r's end up canceling each other out. Okay? And so go ahead and take a moment. We're solving for theta, which means you have to ask yourself, well, if tangent of theta equals √3, what does that mean theta would equal? Okay? Well, positive, so we're talking first quadrant here. And the angle, whether you do your triangles or your hand trick or memorize your unit circle, whichever one you prefer, the angle that gives you a tangent of √3 is pi over 3. Okay? Okay, so that's your extra practice converting from rectangular to polar. If you're still sitting there going, I'm still feeling a little bit weak in a particular area of this, or whatever your questions would be, let us know so we can support you in making sure that you attain mastery.